Welcome all of you again. In the previous lecture, that is the 5th lecture of this series, that is the projectile motion advanced, we have derived this equation: u square sine 2 theta divided by g, where theta is the angle of projection. Okay, but what the mathematics actually tells us. In mathematics, the coordinate systems can be divided into 4 quadrants. We can say this is the first, this is second, this is third, and this is fourth. In the first quadrant, we can say all the trigonometric ratios, identities are positive. In the second quadrant, the sign positive. In the third quadrant, all sign, after that the tan is positive. In the fourth quadrant, cos is positive. Okay, so if sin theta can be written as sin 90 degree minus theta, if the sin theta can be written as sin 90 degree minus theta, is it possible? Obviously we will say no. But if I put a value 2 here and put a value 2 here, then sin 2 theta can be written as sin 290 degree minus theta. Okay, sin 2 into 90 degree minus of 2 theta. Now it is possible. Obviously it is possible, because sin 2 theta is the angle in the first quadrant. Sin 2 into 90 degree minus 2 theta is the angle in the second quadrant. If it is true, then trigonometry allows to tell us range r equal to u square sin 2 theta divided by g. These expressions also can be written as u square sine 2 into 90 degree minus of theta divided by g. Okay, in both of the cases these equations can be written. So range is equal if the particle is thrown at an angle theta or in its complementary angles. And this thing is introduced by Galileo in his book, in his famous book Laws of Two Sciences. In this case the ranges are equal, may not be the maximum height, and time are not equal. Let us see. We know that the expression of the maximum height is u square sine square theta divided by 2g. Then for the value of theta, h, we can say this is h1 equal to u square sine square theta divided by 2g. But if theta is replaced by the complementary angles, that is 90 degree minus theta, then the h2 equal to u square sine square 90 degree minus theta divided by 2g. So it is u square sine square, the sine 90 degree minus theta can be replaced by cos square theta divided by 2g. So from here it is clear that h1 is not equal to h2. If I am talking about the time, total time, the expression of total time is 2u sine theta divided by g. Okay, so for theta, for the angular projection theta, if I say it is t dash, okay, then it will be 2 of u sine theta divided by g. But if the angular projection becomes its complementary angle, that is 90 degree minus theta, in that case the total time of flight becomes 2 of u sine 90 degree minus theta divided by g. Then obviously this thing will become 2 of u sine 90 degree minus theta becomes cos theta divided by g. Okay, so obviously we can see from here that is t prime is not equal to t double prime. The maximum heights and the total time of flight are different, but the ranges are same for if the particle is thrown at the complementary angles of each other. I am always insisting all of you to take the handwritten notes. So just see, range is r equal to u square sine 2 theta divided by g. From here I replace this theta by 90 degree minus theta. Then it will again remain u square sine 2 theta. So theta and 90 degree thetas, the range will be same. But for theta is the heights are same. Just see, u square equal to sine square divided by 2g. And we have just write for 90 degree minus 2 theta, it is u square cos square theta divided by 2g. So the mathematics allows us, if I just add h1 plus h2, then it will be u square divided by 2g sine square plus cos square theta equal to u square by g. So from here we can write h1 plus h2 equal to u square divided by 2g. This 2 is missing, u square divided by 2g. And in the expressions of the total time of flight, if I say for theta it is t1, that is 2u sin theta by g. This for t2 it is 2u sin 90 degree minus theta divided by g, so it will be 2u cos theta by g. So if I take the ratio of t1 and t2, then it will be t1 by t2 equal to tan theta. Okay, t1 by t2 equal to tan theta. If I multiply this t1 into t2, then just see what it is, 2u sin theta into 2u cos theta, 2u sin theta into 2u cos theta by g. If I multiply this thing, then it will becomes 2 by g, u square sin theta cos theta, 2 sin theta cos theta by g. So it will be u square sin 2 theta divided by g, so it will be 2 by g into r. So if the particles are thrown at an complementary angles, then the product of the total time of flights in the two different cases, if I say this is for theta and this is for 90 degree minus theta, in both of the cases the total time of flight, if I just calculate the product of the total time of flights, it is proportional to somehow the range. The equation of range r equal to u square sine 2 theta divided by g. Now in this equation, if u is constant, then there is only one variable, that is theta. So if I say the range will be maximum is dr d theta will be 0, this is the condition of finding the range is maximum, because if u is constant, then only for the values of theta it will be changed, the range can be changed. So it is d dt d d theta of u square divided by g sine 2 theta equal to 0. Since the u squared by g is constant, so we can say that is sine 2 theta. Sine 2 theta is becomes cos 2 theta divided by 2 equal to 0. And from here, since u square divided by g is not equal to 0, so we can say cos 2 theta equal to 0. If the cos 2 theta equal to 0, then it will be cos 90 degree. Then from here we can say that is theta equal to 45 degree. Therefore for the angle 45 degree, the range will be maximum. Okay, the value of angular projections at 45 degree, the range will be maximum. We have done this by following the method of differentiation, but these things also can be found out by the analyzing method. If u is constant and j is constant in a terrestrial region, then we can say the only variations will be sine 2 theta. Then what is the maximum value of sine 2 theta? The maximum value of sine 2 theta will be 1. Okay, from here we can say sine 2, if I replace this thing as the theta max, it is equal to sine 90 degree. So from here 2 theta max equal to 45 degree, sorry 90 degree. So if I divide it by 2, then the theta max is equal to 45 degree. So we can find out these things by the method of analyzation. Okay, we can avoid the differentiation method. As I am always encouraging you to take the handwritten notes, then this handwritten notes gives us that dr dθ equal to 0, and from the difference we get that theta equal to 45 degree. Okay, but if I want to make a qualitative study, what this qualitative study tells us, we just take a look of it for a while. What it represents, for theta equal to 30 degree, h1, that is the maximum height, we can say that is 1 by 4 of u square by 2g. If I put the value of sine square 30 degree, then t1 equal to u divided by g. If I put the value of sine 30 degree here, if I put the value of sine 30 degree in case of equation of range, it will be root over of 3 by 2 u square by g. Similarly, if I put the value of theta equal to 45 degree, then we can get h2 equal to 1 by 2 into u square divided by 2g. t2 equal to root over of 2 u by g, just putting the value of sine 45 degree. The range is u square by g. Okay, if theta equal to 60 degree, then the h3, it is 3 by 4th of u square by 2g. Okay, t3 equal to root over of 3 by 2 u by g, and r3 equal to root over of 3 by 2 u square by g. So if I take all the data together, then at 30 degree and 60 degree the ranges are same. Okay, 30 degree and 60 degree the ranges are same. If I say root over of 3 is 1.732, then it will be 0.866 u square by g. Here it is 0.866 u square by g, which is obviously less than 1. So at theta equal to 45 degree, we can say the range is maximum. Okay, now if I look at on the case of the heights, then we can say it is 1 by 4th of u square by 2g, it is 1 by 2 of u square by 2g, it is 3 by 4th of u square by 2g. Okay, so it is 0.25 into u square by 2g, it is 0.25 of u square by 2g. In case of theta equal to 45 degree, it will be 0.5 of u square by 2g, it is 0.75 of u square by 2g. So if the angular projections is greater, then the maximum height is increasing, okay, in that rate. Now if I talking about the times, then the for theta equal to 30 degree, it is u by g. For theta equal to 45 degree, it becomes 1.414 into u by g, and for theta equal to 60 degree, it is root over of 3 by 2, that is 1.732 divided by 2, that is 0.866 into u by g. So just see, it is 1, it is 1.414, it is 0.866. The time of light is changed, it is increased and again decreased. So from this qualitative study, we can get an idea. The height is monotonically increasing, the ranges are same. In that these two cases, it is maximum, and at that time the time is also maximum. For more time, the particle will be in the air. Since the time of flight for theta equal to 45 degrees is greater, we can say the range is also greater for this cos. So this is the cos behind the ranges becomes maximum. So what we have find out from this differential method and from the analyzing method, it is correct that at theta equal to 45 degree the range is maximum. In addition to that, we get another additional information, the time of flight is also maximum. What I have just told you, it is here. Just see, H1, H2, H3, it is monotonically increasing. T1, T2, T3, T2 is greater than T1 and T3. R1 equal to R3 and less than equal to R2. Okay, so these things we have obtained. And if I talking about the UX, just see, at 30 degree it is 0.866, at 45 degree 0.707, at 60 degree it is 0.5 into U. So just think, when 45 degree the time of flight is maximum and UX is somewhere in the midway between 30 degree and 60 degree, but since the time of flight is maximum, so the range will be maximum. Okay, because range is the product of UX, x component of velocity and time. Okay, so it will be maximum when UX and TU will maximum. So UX in the midway, but T is maximum, so the range will be maximum. So we can pause this video here and you can read what I have written here. Okay, take your time, you may pause this video here. So I think you have paused this video there and you have just done these things, and after that if we just go for the graphic analysis, just see, it is like this. Just compare, these are the values that we have told there. Now I am shifting to the next one for 45 degree. Just see and just look at these values, and for theta equal to 60 degree, just see and just look at these values. Okay, just look at these values here. So I think from this graphic analysis you can get an idea, and this thing, I think that this thing is completely gone deep to your mind, that not only will read the why the condition that is at 45 degree range will be maximum, but what is the causes behind it. At that time the time of flight is maximum and the UX is in the midway between 30 degree and 60 degree somewhere. That's why we can say the range is maximum, and this is also evident from this plotting: 60 degree, 45 degree, 30 degree. Okay, if you know something greater than that of the textbook you have read now, if you know something greater from the videos that you have watched in from the different YouTube channels, so it is your responsibility to share this video to your friends so that they also know this thing. Okay, and please comment if you have any idea to see this range, the variation of ranges for different causes, for different variations. That is at first for the complementary angles, then we have seen that why the at theta equal to 45 degree for the 45 degree angle of projection the ranges will be maximum. So we have seen it in a different way. Okay, just start thinking like this way. Just start imagining the lines that you have learned in your book in a different way. Try to understand the meaning in depth, so after that you can answer, okay, the questions in the exams, in the twisted questions in the exams. Thank you all of you.